Hello everyone. In this video, we are going to start with the basics of functions and how to solve the different questions that might appear in your functions exam. So over here, we have one PDF that I will explain the different types of question that might appear in the function questions. And there's a small worksheet which contains questions from the recent papers so that we can solve this, and it gives you an idea about how your questions would appear in your exam from this chapter functions. Okay, so let's start. Now, functions are not that much very tough to explain or to understand also. Functions have five parts over here. Okay, so let's start with functions. Now, in function, you're going to have like 5 different types of questions. The first one is input function, where you input the values into the equation. The second one is either domain or range. Fourth is inverse function. Fifth is composition function or composite function. Both are indicate the same thing. So we'll start serially. We'll start with input function. So in most cases, in input function, this is the most easiest form of function. For example, they would give you an equation. So we are starting input function. Okay. So for input functions, we have one. The equation would be gx equals to, or we should actually start from the basic. That is, it could be the function equation can contain either the linear, quadratic, or cubic equation. For example, it could be 5x plus 2. In function, what they usually make a change of is that they do not put y the subject of the equation. Instead of y, they use fx. Right, so this is how they write the equations of function. They usually tell you to find the value of f3 or f5. And the question would be like that fx is given as a equation of 5x plus 2. Find find f3. F3 means that you can clearly see that inside the bracket in the equation it was x previously, and now it has 3 in it, which means that we are supposed to take the value of x as 3 and input the value 3 into the equation wherever there was x previously. So F3 will be like this. Instead of writing 5x, you will now write 5 bracket 3 plus 2. So you get 15 plus 2, that's 17. So finally, you can write f3 is equal to 17. This was just the input function that you just have to input the values of x into the equation. Let's do another example over here. For example, gx is equals to 5x square plus 20x plus 13. As I've already stated that any equation can be used as an example for input function, because in input functions you're only in this kind of maths, you're just only inputting the value of x into any equation. It could be linear, quadratic, cubic, fraction, anything. So now they might ask you to find g4, right? So for g4 it will be 5 4 square 24 plus 13. So you can use a calculator and find the value of this entire expression, which is 173. Right, so this is how you are supposed to solve your input function maths. So we are done with the input functions. We'll just put a cross over here. Then we'll move to domain part. Now domain and range are kind of related to each other. So we'll just start with first domain and then explain range along with it. Now, while I was writing the first equation, if you guys remember that I wrote the equation fx equals to 5x plus y first as y equals to 5x plus y, right? And instead of writing y, I chose to write fx because of the function method. Now, this is the similar case. If you're working with the values of x, then you're working with domain. If you're working with the values of y, then you're working with the range. For example, again, another equation can be written as f y equals to 5x plus 10. right? All the values, all the possible values that could be a value for x for this equation are referred to as a different term, which is domain. And all the possible values of y that could be the value of y for this equation is referred with the name of range over here. For example, if you input x equals to 1, then y becomes 5 1 plus 10, which is 15. Right, so you can now say that x equals to 1. 1 is a value of domain and 10 is a value of range, because, sorry, 15 is a value of range, because the value of 15 is an actual numerical value for the data of y. Okay, so as I've already written over here, the domain are all the values of x and range are all the values of y. So for domain calculation, usually they ask you a question in two forms. Either they want the domain exclusion or they want the range from a set of domain given for you. So I'll just write the two different forms of questions that might appear concerning the concepts of domain. Question 1, the question might appear like this: if x is 5x plus 2 over 3x plus 4, and now they want you to find out that x could be a, like, anything could be a value of x except for one value. Okay, so you need to find out that what is that one value of x that cannot be a part of this equation. So they would ask you a question like this: find the domain excluded. So this is basically the maths for the domain exclusion one. So find the domain excluded. What we actually have to do to solve this maths is that you do a rough work to find that value first. You take the denominator and make it equal to 0. So I'll just write it out as a rough over here. Denominator equals to 0. So the denominator of the equation was 3x plus 4 equals to 0, and we have 3x equals to minus 4. So you get minus 4 over 3. So this is the value of x, which could be the value that is not included in the list of domain. For example, in this maths, maybe the list of domain can contain 1 2 3 4 5 7 8 9 10, everything except for this one value. And how can you prove that? You prove that into your mathematical part. That is, you start writing your values as f equals to minus 3 by 4. You input the value of minus 4 by 3, not 3 by 4, over 3 minus 4 by 3 plus 4. So if you start calculating this, you get what? Minus 20 by 3 plus 2 over, this 3 gets cancelled out and you have minus 4 plus 4, which is at the end you're supposed to get, this is 6 minus 24 minus 14 by 3. You get this value at the numerator, and at the denominator you have 0. Whenever a fraction is divided by 0, it eventually gets math error part, right, or syntax error. Your calculator will represent that this is not possible to calculate at this point. This is an undefined calculation. So your entire equation becomes error only because of the value of x equals to minus 4 by 3, which indicates that for this equation, the value of x could be any number except for minus 4 by 3. So which means minus 4 by 3 is not a domain for this equation. So you can write this down as x is not equals to minus 4 over 3. Okay, so this is how you do your maths for domain exclusion 1. So this was an example for domain exclusion. There is another type of maths called domain given, where they would give you a set of domain and they would want you to find out the possible ranges for that specific domain. So this is also a calculation under the domain section. So this is for domain given. In this part, the question might appear like this, that now you have an equation of 3x squared plus 1, and they want you to find the range, like find range when domain is given under a set. For example, a set notation 1, 0, minus 1. Like these are the three domain for this equation, and you need to find the corresponding values of range for each domain. So you can just write it like this: when x equals to 1, you're going to find the value of f1, which is 3 1 square minus 1, and you get what, 2, right? Then again, when x equals to 2, you have to find the value of f2. So you have 3 0 square minus 1, so you get minus 1 over here only. And again, for x equals to minus 1, f minus 1 would be 3 minus 1 square minus 1. The answer is still 2. So the possible ranges for all the three given domain is again can be written in a set format, which is either minus 1 or 2. There's no need to write the two similar domains twice. So these are the range maths that has to be calculated using the different domains provided by the question. So these are the only two types of maths that might appear for your domain calculation. First is domain exclusion, where you have to take the denominator as 0 and find the value of x. And when you input that value of x into the equation, you get your math error indicating that x could be anything except for this value. So this is a domain exclusion maths. Another thing is for domain given, where they would give you a set of values of domain, and you have to find the corresponding ranges for each domain. So we found this out using the input function, and you just have to write the range in a set notation at the end as an answer format. Okay, so I'll just scroll up, and now we are done with the domain function also. So this is done. We'll move to range. Now, as we have already stated, that range are the values of y. In range questions, they usually use quadratic equations to calculate the value of range. So, in most parts, they would give you two types of quadratic equation. The first one is ax square plus c, or it's better to write the equation as fx equals to ax square plus c, where the bx is missing, and another format is fx equals to ax square plus bx plus c equals to 0. Sorry, equals to, not equals to 0, up to c. Now, for these two different parts, we're supposed to carry out the range equation or find out the range in depending on what kind of equation is provided and what kind of process you're supposed to use. The first one is very easy to use. For example, this value over here will always give you the value of maximum or minimum point if the bx is missing. If your question is asking you the value of the minimum or maximum point, when the equation looks like this, ax square plus c, where the bx part is missing, then the constant will be the maximum or minimum point depending on what kind of curve it is. Or minimum point. Again, what kind of curve depends on the sign of a, the coefficient of x square. For example, if you are given an equation of 5x square plus 2, the 5x square coefficient is positive, sorry, x square coefficient is positive, then it will have a positive quadratic graph, which is a smiley graph or upsloping graph. For this kind of shape, this is the minimum point. The graph never steps lower than this point. And the coordinate, like the y coordinate of this minimum point, is the small c given in your question. So in this section, when you're working with smiley graph, you always get a minimum point. So your range should be greater than equal to minimum point, because your graph doesn't have any value below the minimum point, right? This is the least point. So your graph should be, your range, the value for y would be greater than or equals to point C, right? You guys can clearly see this is an upsloping. So graph will never have a point below than C. It will always have points equal to or at a higher level than point C. So you should now write your range as fx is greater than equal to the minimum point. And as you can see that the minimum point over here would be 2, right? Because this was in the position of that alphabet C. So you can finally write fx is greater than equals to 2. No need to draw the graph over here. I just drew the graph for the explanation purpose. Otherwise, the graph is not needed. So this was one example. Another example could be for a negative graph, which is maybe the equation is now minus 5x squared plus 2. So this time the equation is different. Previously it was plus 5x squared, now it is minus 5x squared, which indicates that this time the graph will be a downsloping graph, sad graph, right? This is the shape, and this point is the maximum point. Again, as you can see that this is the highest point received by the curve, and the graph continues to move down slope, moving in a downward direction, which means that the graph has the maximum point at point C and all the points will be below point C. So over here the range should be written as if x less than equal to maximum point, right? Maximum points y coordinate was that C value, small c. So your values for y should start from point C and continue to decrease below that, but it will not be greater than the value of the maximum point. And as from your equation, 2 is again in the place of point C, so you can write if x is less than equals to 2. So you write greater than equals to for smiley graphs, you write less than equals to for sad graph. Now this is the easiest version to find out the range since bx was missing. But if you have this kind of equations in your exam paper, then you have to do completing the square first and then find out the coordinate of that maximum and minimum point. The overall process is same. For smiley graph, you still are going to use the greater than equal to. For sad graph, you're still again going to use the less than equal to. But for this kind of equations, you could easily find the y coordinate of the maximum and minimum point directly from the equation. But when you're working with this ax square plus bx plus c, which is the full format of the equation, now you have to do the completing the square first and then find out the values of your y coordinate of the maximum or minimum point. So you usually do this by converting it like this. Fx can be written as capital A x plus capital B whole square plus capital C. So you can find out the values of capital A, B, C using simple formulas. For example, capital A can be found out using small a. Like whatever the value of small a is will be the value of capital A. And capital B can be found out using, it's going to be B by 2A, and capital C can be calculated with C square minus, C minus b square over 4a. Now these small a, b, c are a part of the original equation, and you convert this to the completing the square format, so you get the values of capital A, capital B, capital C. So in this part, capital B is the x coordinate of the maximum minimum point, and capital C is the y coordinate for the maximum minimum point. Since you are solely trying to calculate the range for this quadratic equation, so only capital C is the most concerned part for our equation. Okay, so let me just write this down over here. This is the x coordinate for the maximum or minimum point. I'll just write the short form, max or mini point. Depending on the positive way or negative way, you will have the smiley shape or sat shape, right? And similarly, this capital C will give you the value for y coordinate of maximum or minimum point. Again, depending on the shape, whatever the shape is, you will write your range and use the maximum minimum point term. So now let's see two examples for this completing the square method. For example, we actually need to do this on the other page. So for example, we have another question of question 5, so question 3. They gave you an equation as if x is equals to 5x squared plus 3x plus 14, and they want you to find the range for this. Now by the equation we have clearly understood that this is going to be a smiley shape since the coefficient of x squared is positive, right? So depending on the coefficient we decide that if it's going to be a sad or smiley. This is going to be a smiley shaped graph. Now we need to find out the y coordinate for this graph. So for the y coordinate, the value for small a is 5, value for small b is 3, value for small c is 14. As we are just concerned about the y coordinate, so y coordinate can easily be calculated using the formula of capital C, which is small c minus b square over 4a. C was 14 minus 3 square over 5 multiplied with 3. So when you calculate this, you get 13.4. Now, as this is a positive graph, the format that you're supposed to use fx greater than or equal to minimum point, right? So the y coordinate of this minimum point is 13.4. So your range should be fx is greater than equal to minimum point and minimum point is 13.4. So this is how you calculate the range for a positive quadratic equation using completing the square method. Now let's see another example where the graph was a negative graph. So question 4, maybe gx over here is given is minus 3x squared plus 2x plus 6. And again the value of a is minus 3, the value of b is 2, value of c is 6. Now using the coefficient of x square we easily understood that x square is minus 3, right? The coefficient of x square is minus 3, my mistake. So the graph will be a sad shape and this time the graph will have a maximum point over here. Okay. So now we need to find out the y coordinate again since we are just concerned about the range. So for the y coordinate we have to calculate the value of capital C, which is small c minus b square over 4a. Small c is 6 minus 2 square over 4 minus 3. Which is 633, or we can just use the fraction as 19 by 3. So the y coordinate of this maximum point is 19 by 3. And now you can calculate the value of the y coordinate. As we have already calculated the value of y coordinate. So you can just write the range for the negative graph. If you go back, the range for the negative graph is fx less than equal to maximum point. So we'll just write range as fx less than equals to 19 over 3. This is how you're supposed to calculate the range for an entire quadratic equation using completing the square, or another method was just concerning about the small c. You can find out the range for this kind of quadratic equation where bx is missing. So we are done with the range function also. So let's just scroll up and cancel the range over here. Lastly, we're still stuck at inverse and composition. So inverse, let's move to inverse function. Okay, so for inverse function, they would usually ask you questions like this. Question 1, they would give you a random equation. And they would ask you to find f power minus 1 x, which means that they're asking you to find out the value for inverse. So the first thing you're supposed to do is that you should write your equation, like at the top of your calculation, write let fx be y. It's just for the simplification of your maths. So we are going to address fx as y at every portion from now. So instead of writing fx, we'll write y equals to, y equals to 2x plus 1 over 4x plus 2. And you start making x the subject of this equation. Okay, so you just invert the equation by making x the subject of the equation. It was originally in a form that y was the subject of the equation. As you're trying to find out the inverse, so you're supposed to take x the subject of the equation. So you take the denominator to the left hand side and you multiply the y with that 4x plus 2. So you have 4xy plus 2y equals to 2x plus 1. And you take all the x together, so it's 4xy minus 2x, 1 minus 2y. So now you can take x common because the main intention was to take x as a common, right? So you can take x common and you have 4y minus 2, and again 1 minus 2y. So you just send everything to the right hand side except making x the subject. So you have 1 minus 2y. This will be divided by 4y minus 2. Now we have already inverted the equation, but if you scroll up to the equation or question, they specifically find out the inverse of function in terms of x. So what you're supposed to do, you will just write f power minus 1 x. You will write the same exact equation, but instead of writing y, you will just write x because they want you to find the inverse of fx function, right? Not fy function. So that's why you'll write the same equation, but instead of using y, you'll just write x over here. Now let's just do another type of math, like whenever they're using fractionating equation or linear equation, it's very easy to work with. But the problem arrives when they want you to use quadratic equation. Okay, I'll just do all kinds of maths. This is an example from fractionating graphs or fractionating fraction equations. Okay, so this was an example from fraction equation. So another equation would be linear equation. Okay, so we'll use this second page. Now they have given you an equation of gx 5x plus 12. Then you're going to do the same working that let gx be y. So we can write y equals to 5x plus 12 and it becomes y minus 12 equals to 5x. Flip the entire equation, you have 5x equals to y minus 12. And you just take x on the left hand side, so it will look like y minus 12 over 5. You have already inverted the equation. For the inverse function of g, you can just write x minus 12 over 5. Right, so this is how you're supposed to do the inverse function for linear equations. Now moving to question 3. Right, since we are done with fraction graphs and linear equation, again in quadratic equation, they are going to use the same two formats as ax square plus c or ax square plus bx plus c. So it's going to be like this, 5x square plus 10, right? Sorry. Then you have to do the same working that let hx, this time you have hx, so hx be y, and you can write the equation as y equals to 5x square plus 10. So you start making x the subject, everything on the right hand side, and you have x square, so it becomes y minus 10 over 5. Remember, you're not trying to make x squared the subject, you have to make x the subject. So you just shift that square to the right hand side, it becomes a root over the entire fraction. So y minus 10 over 5, entire fraction under a root. And since you're trying to find out the inverse of hx function, so it will be h inverse x, it will be x minus 10 over 5 under a root. Instead of writing y, you just write x minus 10 over 5. Okay, so this is the equation for hx in form of this is a quadratic equation, but the simple quadratic equations. Okay, so we'll just write simple quadratic equation. The problem arrives when you have to work with the entire quadratic equation and you need to find out the inverse of that function. For example, question 4, maybe now you have gx as 5x squared plus 10x plus 15. Now if you have to find out the inverse, and if you carry on doing the same process, you just do like this: let gx be y, and y would be equal to 5x squared plus 10x plus 5, and you start making x the subject, which is basically y minus 5, sorry 15, y minus 15 5x squared plus 10x. Problem is that the number of x is not equal over here. At one portion you have x squared, at the other portion you have x, so you possibly cannot x a common from this part, or possibly cannot make x the subject from this section. What are you supposed to do is you have to first make this in a form of completing the square, so that it's easier for you to make the subject x for this entire equation. So including the using the same format of completing the square, that is I'm going to convert this into a form of capital A x plus capital B whole square plus capital C. So you can find out the value of A as 5, right? Because the value for A was small a. The value for capital B would be small b over 2a, right? Which is basically 10 over 2, 5, that's 1. And the value for capital C would be C plus b square over 4a, which is the value for C is 15. The value for b square over here is 10. So you have 10 square over 4 multiplied with 5. And you get the value of c as 20. So you can finally write the entire quadratic equation in a form of gx. Capital A would be 5, x capital B is 1, and capital C is 20. So instead of writing the equation as a quadratic form, you can now write the equation as 5x plus 1 whole square plus 20. So you take this 20 to the left hand side, it becomes y minus 20, 5x plus 1 whole square. And just flip the equation, take that 5 to the left hand side. This entire thing will be divided by 5. Now you have to change the position of the square. So you have x plus 1, y minus 20 over 5, everything under a root. As you have an extra 1 on the left hand side, so you're supposed to take that 1 to the right hand side again. So equation would be entire thing under a root, and this entire fraction will be subtracted by 1. Right, so this is how you inverse a quadratic equation, an entire quadratic equation using completing the square. Lastly, you have to obviously write your answer as g inverse x. So your answer should be g inverse x. Everything would be same, but instead of writing y, you would write your answer as in terms of x. This entire fraction is subtracted by 1. So these are the 4 formats of linear equations. If you go back to the first one is fraction graphs, which is very easy to do. Nothing else you have to do. You just have to make x the subject and invert the overall equation. Same for the linear equation and same for the simple quadratic equation. But only for the entire quadratic equation, you have to do the completing the square and then find out the equation in terms of y and make x the subject and find out the value for the inverse function. Okay, so we're done with the inverse function also. So we'll move to the very top and put a cross over here. Lastly, for the composite function, For composite function, in most cases, they will give you two different equations for here. For example, they would give you hx as 5x squared plus 2 and gx as 10x plus 4, 14. Okay, 4 over here. So they might ask you to find out hgx. So hgx is that you have to input the gx in equation into the hx equation. It indicates that input the value, the equation of gx into hx. So input gx into hx. So if I carry on doing the working, at first you will write hx separately. The hx equation was 5x squared plus 2, and now the value of the gx, or the equation of the gx, will be working as a value of x for this hx equation. So you can write h gx. It indicates that instead of writing x, now we have wrote gx inside the bracket, which means that gx is now acting as a value of x, right? If you guys remember the input function, this is related to the input function. Now the equation only has x over here beside 5. So instead of writing x, you will now write 5, as you are using the concepts of input function. So instead of writing x, we'll write the value of x, which is basically the equation for gx. So we'll now write 10x plus 4. As we have a square on top of the x in this equation, so we'll have a square over here also. And now you need to simplify this term using the concepts of algebra, that is a plus b whole square, which is 5. I'll just do the working for the 10x plus 4 whole square the side. It will be 100x square plus 80x plus 16. Okay, I'm just doing the rough work at the side. So you're going to multiply 5 with 100 x square plus 80x plus 16 plus 2. So you have 500 x square plus 400, 400 x plus 5 into 16 is 80, and we have another 2, so we can write 82 at the very end. Right, so this is how you can calculate composite functions using one function and inputting that function into another equation is an example for composite function. Right. Another example could be that they might also ask you to find out GHX. For example, GHX. So always remember the pattern that you have H at the very first, so you are going to input the value of Gx into the Hx equation. Similarly, you have G at the very end. Now you are going to use the equation of Hx into the Gx equation. So you'll write Gx very first, which is 10x plus 4, and then instead of writing gx, you will write ghx. Now we have x over here, so instead of writing x, we can write 10. Inside the x, you will write the value of hx, which is 5x square plus 2 and plus 4 over here. Then multiply the values, that's 50x square plus 20 plus 4, which is basically 50x square plus 24. So this is the value for, okay, then you shouldn't, yeah, I mean, it's not needed to write two brackets on the later sections. You can just write GHX over here. So this is how you're supposed to do composite functions over here. Okay, since we're done with all the different types of functions that are asked in the question, so we'll move to the worksheet now.